All right. So the first thing I want to ask you, what is the difference between a sequence and a series? Right. When you have a series, the terms are added together. That's the difference. Yesterday we dealt with a sequence. A sequence can be just a set of numbers. Okay? They can be in a pattern, they cannot be in a pattern. You can add or subtract to get to the next one, or you can multiply, divide, square each one, whatever. There's different kinds of sequences. The kind we worked with yesterday was arithmetic sequence, where you had to add or subtract to get to the next number. So that's a specific type of sequence. Well, now we're going to deal with an arithmetic series. So what we're going to do is we're going to take those numbers and add them up. That's all. Okay? Now, we're going to need the formula that we used yesterday to find any term of a sequence. This is to find any term of a sequence. And this is arithmetic. You take the first term plus n minus 1 times d. And we're going to need that today. Okay? But an arithmetic series, and let's take a series of numbers. Let's take I don't know, 5 plus 12 plus 19 plus 26 plus 33. Okay? And rather than, and I'm just going to show you how this formula works, rather than just adding those all up, that would probably be the easiest. Let me show you how this formula works. S stands for sum. The N stands for what? What does the N stand for? The number of terms we have. So the sum of so many terms is equal to N times T1. What's T1? First term. Plus Tn. Same as that N. Okay? Divided by 2. Okay? That's N, I'm sorry. That's the number of terms. Okay, N. All right, so let's see how it works. I want the sum. How many terms do I have? Up there. 5, right? So the sum of the first 5 terms is equal to N is 5 times, what's the first term? 5. What's T of 5? What's the fifth term? 33, right? So it's the first term and the last term divided by 2, or the average of the two terms, first and last divided by 2. That's how the formula works. And so I have 5 times 5 plus 33 is 38. 38 divided by 2 is 19. 5 times 19 is 76. No, it's 95. Sorry. And so if you were to add those all up in your calculator, you would get 95. That's how the formula works. Okay? Easy enough? Yeah.
So I still have to count all the numbers, how many numbers are in the series?
So
You still have to count up how many numbers are overall in the series, right?
not at all. Well, yeah. But let's play this out. This is the only formula we're going to be using today. All right, so let's take this. Let's take another one. Let's take 2 plus 5 plus 8 plus 11 take that. Okay? So we don't know how many numbers are in the series, right? And let's find the sum of the first 25 terms. Okay? We're going to find the sum of the first 25 terms of this particular series. All right. So, the sum of the first 25 equals, I'm going to use my sum formula here, n 25 times the first term, which is 2, plus the 25th term. Do we know what that is? We can find it. I don't know what the last term is. I have to find it. And then whatever is going to be divided by 2. Okay, so let's find the 25th term. Right? I knew that. I need to find the 25th term. So I use that formula, T1 plus n minus 1, 25 minus 1, times the common difference. And what is the difference? You can look at it. What's the common difference? 3. This will tell me what the 25th term is. So the 25th term, you have 2 plus 24 times 3. And so the 25th term here is 74. Jack, does that make sense? Now I have the first term plus the last term divided by 2. That's the average of the two terms. 2 plus 74 is 76. 76 divided by 2 is 38. 25 times 38 is 950. I'm betting. Right? 40 times 25 is 1,000. So 40 times 38 would be 950. Okay? And that's the sum of the first 25 terms. So we don't always know how many terms there are. Okay? Any questions on that? Nate, you okay with that?
Yeah.
Alex, did you get your question answered? Yeah. All right. Okay. Let's take another problem here. Those are the two formulas that we're going to be using. One, you can find a term. The other one, you can find the sum of a series. All right. First of all, the directions might say evaluate that. Dalton.
Yes.
If we want to evaluate that, tell me what they are asking you for in English.
Okay, so what you're going to do is...
No, not what you're going to do.
Oh.
Just tell me what we're asking for.
Oh, well, what does 5 minus 4... what does 5 minus 4...
Now, what are we looking for? Tell me what I'm looking for.
The sum of all the steps.
The sum of the first
80.
80 terms. That's all. I mean, just so we know that this is a summation symbol, and I want to find the sum of the first 80 numbers of this series. Okay? Using our formula, okay, sum of the first 80 equals 80 times. How do I know what the first term is? put in 1 for n. Question?
The reason on this, but you know, if n was 2, you plug that into the equation, right?
Correct.
So why not just factor it into the equation and just get rid of the bottom, n equals whatever. If you just have that, if it was 2, just have 5 minus.
Because if I put n equals 2, are you talking about on the bottom of the summation sign?
Yeah.
If I do that, then I'm not getting the. We're starting off with the second term of the series, and so the number of the series would not be 80 of them; it would be 79. If you're going from 2 to 80, if you go from 5 to 80, then you're only looking for 75 terms. Does that make sense? What I'm saying?
Yeah.
So let's find the first term, because this is what I need: the first and the last. The first term is 1. 5 minus 4 times 1. The last term, 5 minus 4 times 80. 5 minus 320 is a negative 325. No. Plus negative 315 divided by 2. You take the first and the last. First term, the 80th term, divided by 2. Yes?
That's the sum of the first 80 terms?
Yes, that's what this is. This is a summation symbol. It means the sum. All right? Now what you can do here, you can reduce this way, the 2 and the 80. And so I've got 40 times 1 plus a negative 315 is a negative 314. 4 times 14 is 56, 1256. That gives me a negative 1256. I think if my math is correct, I think it's negative 12,560. Is that right? Okay. All right. I was telling my first couple hours, you guys eventually will bypass my knowledge of math. Especially if you go on to college and you take math courses beyond calculus and there's other courses, linear algebra and differential equations. So some of you will bypass math, but you will never get better at mental math unless you practice. That's the way I learned was mental math, because we didn't have calculators when I went to school. So you learn certain tricks. Okay. It's a nice skill to have, especially if you're teaching mental math. But you got to practice too. But you guys will definitely, as far as your knowledge of math, some of you will go way beyond what we know here. All right. So that's the sum of the first 80 terms. Have any questions on those? All right. I think we're getting down to all right. That's to find any term. That's what we dealt with yesterday. Today we had the sum, which is n times, think of this as being the first term plus the last term divided by 2. The average of the first and the last term. Okay? And those are the two formulas you'll be using today. Your homework is going to be page 710, 712, 8 through 50, the evens, and 53 through 55, all.